Hello, and welcome to our third video on partial fraction decomposition. In this case, we're going to tackle denominators with repeated linear factors. And if you're not sure what that means, we'll talk about it in a moment. But let's start off like we know how to do. First off, we decide, is this proper or improper? This is a proper rational expression because the degree of the numerator is less than the degree of the denominator. So our next step is to factor out our denominator. So we get x plus 18 over, we can take out a common factor of x, and we'd be left with x squared plus 6x plus 9, which turns into x plus 3 times x plus 3, or x plus 3 quantity squared. What we have here is something called a repeated factor. X plus 3 is being as a factor not once but twice. It is still a linear factor. So we have not two, but three rational expressions to think about. The first has a denominator of x. The second has a denominator of x plus 3. And the third has a denominator of x plus 3 all squared. Because, in essence, these are all linear factors. This is just a linear factor being squared. We have to have our constants on top. But we're going to have a, b, in this case, c. From here on out, it's really no different than the other problems that we've seen before. We multiply by our LCD, which is x, times x plus 3 quantity squared. That will get rid of this entire denominator here and leave us with just x plus 18 on this left-hand side. On the right-hand side, the x would cancel out with this x, but we'd have a times an x plus 3 quantity squared. Plus, one of these x plus 3's would cancel out with one of these, so we'd have b times an x times one of these x plus 3's. And finally, in this last fraction, the x plus 3 all squared would cancel out, and we'd be left with just plus c times x. And now we're going to do like we've done before. Multiply out and simplify as much as we can. So this becomes x squared plus 6x plus 9, which conveniently we have over here. And if we distribute the a through, we get a times x squared plus 6ax plus 9a. We multiply bx through and get plus bx squared plus 3bx. And then we have this plus cx right here. Now again, let's group all of our like terms together. We have ax squared plus bx squared, or a plus b x squared. So we put our linear factors together of 6a plus 3b plus c x. And then we only have a one constant term here, which is 9a. So instead of two equations, we're now going to have three. You might say, well, we got an x squared here, but we don't have one here. Which means that since the coefficients have to be equal, a plus b better equal 0. Our linear coefficients now are 6a plus 3b plus c better equal 1. And 9a better equal our constant on this left-hand side, which is 18. It's easy to see that we can solve for a. Matter of fact, the rest of it here is just a little bit of system of equations. So if you want to skip this, you can. But I'll walk through it. A equals 2. We can use that over here. 2 plus b equals 0, or b equals -2. And if we know a and we know b, we better be able to figure out c. So 6a, oops. So 6 times 2 plus 3 times -2 plus c better equal 1. 12 minus 6 plus c equals 1. 6 plus c equals 1, or c equals -5. Now, since we know A, B, and C, we should be able to write our partial fraction decomposition. So A is 2 over x plus B is negative 2 over x plus 3 plus C is negative 5 over x plus 3 quantity squared. And this is our partial fraction decomposition when we have repeated linear factors.